Morning, everyone. Today we'll discuss about what's called pointers and give you some example on pointers. What are pointers? Pointers are basically a memory location in the computer. So let me show you. It's basically a reference to a location in memory. So let's say we had defined a variable int, kind of like the food truck menu you had, let's say rice. And this rice costs $2.99 or something like that. Remember that food truck project you had to do? So let's say int rice equals $2.99. Now, if we say cout, basically we're saying print this, and then we use the ampersand, and then say rice, for example. Now, if we print this, it will show us the address. This is just a warning. Oh, I said int. Let me put 3. So when I print this, what do you see here? The hexadecimal. This is basically the location of where the variable rice is held. Does that make sense? So this would be what? The location. Now, let's say if I say int, let me just keep it all in the same place. If I say int, and then I put this symbol, the asterisk is what's called a pointer, and then say rice pointer or something like that. Okay. And now if I say rice pointer, by the way, once you put the asterisk there, you don't have to put it again one more time. So if I say rice pointer equals and then say, now here I can say the ampersand, okay? Right, now if I print cout and then say rice pointer, let me put a slash n. Put this at and just add another line. How about that? I just want you to see it. Are the two lines different? They should both look the same. You see that? So if we just say cout at rice is the memory location, or if we use it as a pointer, we are saying it, they are both the same. So pointer is basically what? It points to a memory location in the computer. Okay? So you use it as to reference it. Now this presentation discusses it into details of what pointers are, right? Pointers and the address operator, the variable relationship between arrays and pointers, arithmetic, initializing pointers, comparing pointers, and so forth, right? Pointers as functions, the parameters, pointers to constants and constant pointers, dynamic memory allocation, returning pointers from functions, pointers to class objects, and so forth. So it goes into details explaining what everything means. So each variable in programs is stored at the unique location in memory that has an address. This address, the hexadecimal that had the x's, the zeros, the numbers, that is the address location memory. So use the address operator, the ampersand, to get the address of a variable. So here, this will be int num minus 23 will be cout at num, prints the address in hexadecimal. Okay. So a variable, the pointer variable is a pointer that holds a variable that holds an address. It provides an alternative way to access memory location, and the definition int asterisk pointer, it can hold the address of an int or the variable int pointer points to has type int. The spacing the definition doesn't matter. It's called the asterisk is called the indirection operator. Okay, so the way you assign it, and the memory layout. So num that it shows you where that points to. Okay. An array name is the starting address of an array. So you have int value, these values, starting address of the hexadecimal. So if you say cout vowels displays the hexadecimal. But if you say the first element, then it will display, if you say the index is 0, it will display the first element in the array. An array name can be used as a pointer constant, so you can have int values and then put the asterisk in. So this would display for. A pointer can be used an array name. So here you have int asterisk or the pointer val pointer vowels, and then you have cout val pointer 1 displays 7. Pointers in expression, so you have int vowels 4, 7, 11, and then int the pointer val pointer equals vowels. So how about if you say +1? So it means you're adding the size of the int +1 to it. And you must use the parentheses. Array notation will be vowels I is equivalent to the pointer notation, so say the pointer symbol vowels plus I. So now bound checking is performed on the array, and you can use some of the examples that exist. So an array element can be accessed in many ways. So array access method and then the example, and how you can access each value of the example that we have seen earlier. Pointer arithmetic. So some arithmetic operators can be used with pointers. So increment and decrement operators, plus, plus, minus, minus. Right? Integer can be added to or subtracted from pointers using the operators. One pointer can be subtracted from another by using the subtraction operator. Assume the variable definition. So int vowels 4, 7, 11, and then the pointer, how you assign it. And then you can say val pointer plus plus or val pointer minus minus. So you're subtracting the second, basically the position. So assume the variable definition. So you have int vowels, and then when you assign it, so the example of the use to plus to add an int to a pointer. So you can use this. So the position, it will be from the beginning. You're adding 2 to it, so it will point you to the last position. So assume the variable definition. So example, if you say val pointer equals vowels, and then here you're saying whatever val pointer is, add 2 to it. Okay. So which takes you to the last one. You can do a pointer subtraction. So this prints to the number of ints between val pointer and the val. You can initialize to null or to 0. So you can say int the pointer equals null, and you can initialize to address of other variables. So you can say int num, and then num pointer equals the address at num. Okay, or int val is size equals comma, and then the second one int pointer val pointer equals val. So, and then the initial value must have the correct type. So here you said float, and then here you're saying int. It doesn't work. You have comparing pointers. You have relational operators can be used to compare addresses in pointers. Comparing addresses in pointers is not the same as comparing content by pointer. So here you have if pointer 1 equals pointer 2, and here you have if the pointer 1 equals the pointer 2. So this compares content, this compares the address. You can have it as function parameters. A pointer can be a parameter. It works like a reference parameter to allow changes to argument from within a function. So a pointer parameter must explicitly dereference to access the contents as that address. So it requires the asterisk on a parameter in a prototype and heading. So here you'll do void get num int and then pointer. The asterisk in the body to dereference the pointer. So this you're getting from the user, and then address argument to the function in the call. So this is as a function parameter. You have void swap int pointer x int y, and then a temporary. So int temp and then temp equals the pointer x. So here you say the pointer x equals the pointer y, and then hold the y in the temp. And then int num1 equals 2, num2 minus 3, then you swap the 2. This is your function call. Can have pointers to a constant, cannot change the value that is pointed at. So constant pointer, the address in the pointer cannot change after the pointer is initialized. So pointers to constants must use the word constant keyword in the pointer definition. So you say constant double tax rate as an array here, and then constant double rate pointer. So you use constant keyword for pointers in the function headers to protect data from modification from within the function. So pointer to constants, what does it mean? So the asterisk indicates that the rate is a pointer, and then the constant double, this is what the rates point to. So basically, rates is a pointer to a constant that is double. So you have constant pointers defined with constant keyword adjacent to a variable name. So int class size equals 24. Int constant class pointer equals the address of class size. Must be initialized when defined, and you can use it without initialization as a function parameter, and initialized by argument when a function is called. So a function can receive different arguments on different calls, while the address in the pointer cannot change. So the data at that address may be changed. So this is what the address is pointing to, indicates that the pointer is a constant pointer. Okay. So again, as you see, the author goes into details and what's covered in the book. But my recommendation is run these examples and see it as practice as the page that's given to. So these are dynamic memory example. Try to take this, run it, and test it. So here you have int count and array pointer, and then cout new int, and then how many students, and get that from the user. Count equals new int, and then get that from the user. Array pointer equals new int, and then do a loop on that, and then enter the scores from the user. So you can use delete to free dynamic memory, the array to free dynamic array memory, and say delete the array and the array pointer. And look at some of the examples that exist in there. So dangling pointers and memory leaks. A pointer is dangling if it contains the address of a memory that has been freed by a call to delete. Solution is set to such pointers to 0 as soon as the memory is freed. A memory leak occurs if no longer needed dynamic memory is not freed. So the memory is unavailable for reuse within the program. So the solution is free of dynamic memory after use. Java does very well with this. Pointers can be return type of function. So you have int ask new num, or sample code that you can look at and try to run those codes. The function must not return a pointer to a local variable in the function. So the function should only return a pointer to a data that has passed to the function as the argument to dynamically allocated memory. And then you can have pointers to a class object and structures. So you have struct student and then class square, and then the students, and then you have student pointer pointing at the address. Okay, you can have it as an array, and then array pointing to square pointer to the address of the array square. You have simpler notation than the pointer, the dot member. You can use student.pointer, dot student ID, and then use the format pointer using the arrow. You can have a student pointer and student ID, and then student pointer set side if you want to assign a value in place of the form using the dot pointer dot member. This format. You can allocate dynamic structure variables and objects using pointers. So you have student pointer, new student, and then can pass values to a constructor. So you delete the cost destructor to be invoked, and then delete the square pointer. Look at some of the examples that exist today. So structure of object pointers as a function parameters. So pointers to a structure or an object can be passed as parameters to functions. Such pointers provide a pass-by reference parameter mechanism. Pointers must be dereferenced in the function to access the member field. Memory that's allocated with a new should be deallocated with a call to delete as soon as the memory is no longer needed. This is the best done in the same function as the one that allocated in the memory. For dynamically created objects, new should be used in a constructor, delete should be used in the deconstructor. So when you see the word new, this is initializing a new object as with Java. Selecting members of the object. So the situation a structure object contains a pointer as a member, so there's also a pointer to the structure object. So how do we access the pointer member? Via the structure object pointer. So here you have struct grade list, string course num int grades. So general test one, test pointer, and so forth. And then some of the objects for selecting members. So I would recommend that you look at or run the program, the examples that you have in the text.